In this series, this is the second video. Mm, uh, in the previous lecture, we have discussed about the point estimation using maximum likelihood estimator. Now it is interval estimation. Here the population parameter is theta, and T1 and T2 are different two statistic based on the same sample observation. Probability of T1 less equal to theta less equal to T2 will be 1 minus epsilon, where epsilon is a very small positive number. The interval T1 comma T2 is confidence interval with the parameter theta with confidence 1 minus epsilon. So if epsilon equal to 0.05, 1 minus epsilon becomes 0.95. We call it 95% confidence interval. Here there are some examples. If epsilon equal to 0.05, 0.01, 0.001, the corresponding confidence of the interval will be 95%, 99%, and 99.99%. We all know what is the normal distribution curve. It is symmetric about x-axis. If you follow the standard normal distribution, um, this curve in this slide, this curve is a normal distribution curve, and the total area under the curve above x-axis is 1 unit. Now, if you take 2 points minus 1.645 to plus 1.645, the 90% of the area has been covered. If you take another 2 points minus 1.96 to plus 1.96, it will be 95% area covered. And again, if you take minus 2.576 to plus 2.576, 99% area will be covered. Now we will solve a problem from the sample of size 49. First of all, you should know that large sample means the sample of size greater than 30, and if it is less than 30, the number of sample, it is called actually small samples. Now from the sample of size 49, that means it is actually large sample. The problem based on the large sample is very easier compared to the problem based on the small samples less than 30. So focus on the problem. From the sample of size 49 drawn from a normal population of standard deviation 2, find the interval if the mean of such sample is 3. It is given. Okay, so from the problem, what is given to you? The sample size is 49, the population standard deviation is 2, and of course the sample mean is 3. Let us assume that population mean is m. As we know that z equal to x bar minus m divided by sigma by root n. Now this formula is valid only for the large sample when the sample of size greater than 30. So z equal to x bar minus m by sigma by root n. Here the random variable is x bar. So z will be a new random variable, will be a new statistic. Since we are studying statistics, z is a new statistic which follows standard normal distribution with mean 0 and standard deviation is 1. Now from the given data, minus 2.58 to plus 2.58 is 0.990. Now what is given to you? It is integration 0 to 2.58, integration 0 to 2.58, phi z digit. Phi z is the standard normal distribution probability density function. Okay, so onwards 0 to 2.58 is 0.495. That means we can say that since the normal distribution is symmetric, minus 2.58 to 0, that portion, minus 2.58 to 0, that portion is also 0.495. Okay, so minus 2.58 2 plus 2.58, what will be the total area? The total area becomes 0.495 plus 0.495. One portion has been given to you. That is why we can write that minus 2.58 to plus 2.58, the standard normal distribution, the total area under this curve will be 99%. But according to the previous slide, look at the z. Z is x bar minus m by sigma by root n. So we can write that minus 2.58 x bar minus m by sigma by root n. Just replace the value of z equal to 0.990, and of course after some calculation, after putting the value of x bar, you can find out the range of m. So 99% confidence interval of the population mean small m is given by x bar minus 0.72, x bar plus 0.72. Just put the value of x bar according to the question, x bar equal to 3, and the confidence of the interval will be this. Okay. Now let me discuss some two important distribution. One is chi-square distribution. First of all, the density function will be looks like this: fx equal to e to the power minus x by 2, x by 2 to the power n by 2 minus 1, divided by twice gamma of n by 2, where n is a number of sample size n, x is varying 0 to infinity. Now some observation: we should note that n is a parameter and it is also called degree of freedom. If you calculate the mean of the distribution, the mean will be n and the standard deviation will be root over of twice n. Now important result, if z1, z2, zn, there are n independent standard normal distributions. z1 follows normal distribution, z2 follows standard normal distribution, zn follows standard normal distribution. Then z1 square, z2 square plus dot dot zn square, they should follow chi-square distribution of n degree of freedom. This is an important result. Another curve of z distribution, it is not a symmetric curve like normal distribution. The curve valid from 0 to infinity, the curves looks like this. Another one distribution function is student t distribution. It is very important distribution for in the course of statistics. The density function is given by this: ft equal to 1 by root over of n beta of half comma n by 2 into 1 plus t square by 2 to the power minus n plus 1 by 2. That t is between minus infinity to infinity. Now there are some observations. The parameter n is also called degree of freedom like the previous distribution, but the mean is 0 and standard deviation is n by n minus 2. And one thing you should observe, that if n is very large, then mean is still 0, but the standard deviation is tends to 1. Okay. T curve is symmetric about 0. If you draw the T curve, it will be symmetric about the y-axis, and it is extended from minus infinity to infinity like normal curve. For sufficiently large n, T curve is approximately equal to standard normal curve. Now here I already told you that if n is very large, standard deviation becomes 1 and mean is already 0, and if n is very large, the curve looks like normal curve. Let me give you the difference between these two distributions. One is student t and one is standard normal. Here is the distribution. Standard normal distribution is the upper curve is standard normal distribution, and there are few distribution t distribution with different parameters has been shown in the figure. Now let me discuss very important result. The situation is very simple. x1 x2 dot dot xn, this is the complete set of population, and sample of size n has been given: small x1 small x2 dot dot small xn. Obviously small n is less equal to capital N. As we have defined earlier, population means m, sample means x bar, population variance is sigma square, and sample variance is capital S square. Now let us define t, small t. Another statistic is denoted as x bar minus m divided by s by root over n minus 1. Without proof, you should remember that this t follows student t distribution with n minus 1 degree of freedom. So in the previous probability density function, this you should write the probability density function replacing n by n minus 1. Now, direct application of the previous remark of problem number 2. The marks obtained by 17 students in an examination have mean 17 and variance 64. Find 99% confidence interval of the mean of the population of marks assuming to be normal. Okay, the sample size is 17. It is not a large sample. So we cannot apply x bar minus m by sigma by root n as normal distribution. We cannot apply those things because those things will be applied if the sample size is greater than 30, large enough. So what is given from the problem? X bar is 57, s square is 64, and n is 17. Now let us fit t equal to x bar minus m by s by root over n minus 1. Just following the previous remark, this should follow t distribution with 17 minus 1, that is n minus 1 degree of freedom. So t equal to 57 minus m by 2 if we put the value of x bar and n. Now what is given to you? It is given that probability t greater than 2.921 equal to 0.005. As student t distribution curve and standard normal distribution curve is symmetric about x-axis, symmetric about y-axis. So we can say that from minus infinity, from 2.921 to plus infinity, that is onwards of the probability 2.921 is 0.005. Up to, that means we can say that up to from minus infinity to minus 2.921, the probability is also 0.005. Okay, let me repeat it. What is given to you? It is given that probability t greater than 2.921 equal to 0.005. That is from the point 2.921 to plus infinity, it is 0.005. So we can say that minus infinity to minus 2.921, the probability is also 0.005. If you note the point that this distribution is a symmetric distribution about y-axis. So we can say that probability, since the total probability is 1, probability between these 2 points minus 2.921 and plus 2.921 is basically 99.99. See, just I have calculated that since probability t greater than 2.921, probability t less than minus 2.921 is 0.005. This point is this is the key factor of the problem. You should understand this key factor, otherwise you cannot solve the problem. In other words, between 2 points minus 2.921 and plus 2.921 is 0.99. So just put the value of t, as we have computed already that t equal to 57 minus m by 2. So this will looks like this, and hopefully if you calculate the interval for m, it will looks like probability of 51.15 less than m less than 62.84 equal to 0.99. and so 99% confidence interval will be this. Very important problem, nothing in the problem, just you should identify that this will be t distribution. No, it will never be standard normal distribution, since we do not have the enough sample size. It is 17 sample size. 17 means it's a smaller than 30, so you should go for t distribution instead of standard normal distribution. If it is greater than 30, we can go for standard normal distribution. Still the process is same if you go for standard normal distribution or student t distribution. Both distributions are symmetric about y-axis.